All right, so we got two questions here. Okay, one's just an inclined plane question, the other's a friction question. All right, so we'll start with the inclined plane question. If you are lowering a box down a ramp, which direction are you pulling? Up. All right, that's kind of the trick to this question. All right, so we have this applied force that's up the ramp, but the ramp is so slippery or steep or both that the box is still moving down the ramp even though it's being pulled up. All right, we know that the acceleration, okay, up the ramp, or sorry, down the ramp is 1.3 meters per second squared. Okay, and we know that the force of friction is 25 newtons. Which way is that acting? Up the ramp. Yeah. Okay. If the box is moving down the ramp, then friction's acting up the ramp. So the force that's acting down the ramp is F parallel, and we know that the box is 40 kilograms. Okay. That's what we know here at the beginning. Okay. We are looking for the tension in the rope. That's essentially the applied force. All right. So 1 mark if they've got some givens written down there. All right, I need to calculate F parallel if I'm going to calculate what the tension in the rope is, because I've got to use sum of all forces for that. Okay, so I'm going to need F parallel. Okay, I know that this angle here is 30 degrees. Okay, so this angle here is 30 degrees. So when we calculate FG, that's going to be 40 times 9.81, right, which will give us 392.4. newtons, okay, which means that F parallel is going to be 196.2 newtons, because F parallel will be the sine of 30 times 392.4. Okay, so that comes out to 196.2. Give them 1 mark for calculating F parallel. Okay, our next mark, we have to calculate our net force. What method am I going to use for that? Sum of all forces or M times A? M times A. I don't have all the forces yet. I'm going to use the net force from M times A to do sum of all forces to get my missing force. All right, so M times A, okay, that'll be 40 times 1.3, so you can give them a mark for that. All right, so our net force is 52 newtons. That's down the ramp. Okay, then we will use the sum of all forces to calculate our missing force. So we'll have our applied force, which we're actually going to call a tension, okay, plus our force of friction plus our F parallel. Okay, so we're going to take the F friction and the force parallel over to here. So we'll have F net minus the force of friction minus F parallel will equal our applied force. Give them a mark for that. That's going to look like this. 52 newtons minus negative 25 newtons minus 196.2 newtons. Okay, my 196 is positive, my 52 is positive. I made up the ramp negative, okay, because the box was moving down. So okay, I always make negative the other way. It doesn't matter what you made it, because your final answer isn't going to have a direction on it anyway, because it's tension. Okay, you needed to have the directions right when you did this in order to get the right number. Okay, all right. So our applied force, or the tension in the rope, okay, will be 52 minus negative 25 minus 196.2. All right, which gives us a force up the ramp of 1.2, because I think we only have 2 significant figures here, right? We have 2, right? So our tensional force in the rope is 1.2 times 10 to the 2 newtons. They must have the newtons, okay? If they have a direction, it's not wrong, okay? But because it's tension in a rope, we don't necessarily have to give a direction on that, okay? If you wrote up the ramp, that's fine too. Okay. All right, so that one is out of 5 marks. The tension is the 5th and final mark in that one. Any questions on number 1? All right. So question number 2, very little math in this question. There's a big box, and despite my enormous strength, I cannot move it, because exerting 3,500 newtons worth of force is a lot. Okay, that means I'm jacked. Okay, so I'm pushing with 3,500 newtons worth of force. Okay, on this level floor. Okay, the box, they don't even tell me the mass because it's not important. Okay, I push that way with 35 newtons. The box doesn't move. How big is friction? Okay, friction's the same. All right, that's good. Give him a mark. Okay. If I want to calculate the mass of the box, I need to calculate the normal force. Why will that help me get the mass of the box? Because on a level surface, the normal force is equal to gravity. Okay, that's the trick with this question. Not a lot of math in this question, okay, but it's tricky in that way. All right, so I'm going to divide both sides by mu to get the normal force. Okay, so give them a mark if they got to that step there. Okay, and so the normal force will be 3,500 divided by mu, which was 0.937. All right, so there's my normal force, 3,735 newtons, with some decimals after that. Okay, now I'm going to say that that is the force of gravity, and it equals m times g. Okay, so I'm going to go 30. So I'm going to go force of gravity divided by the acceleration due to gravity gives me mass. Okay, that's 3735 with the decimals, obviously, divided by 9.81. If they have something like that, give them a mark. That's their third mark. Okay, fourth and final mark. The mass of the box is 380 kilograms. That's huge. It's like putting a car, a big one, in a box and saying, push this box. Okay, yeah, it'd be pretty hard. All right, so 380 kilograms. Okay, it's not a car, but it's big and heavy. It's a golf cart or something in a car, in a box. Okay. Sorry, 381. Yeah, I didn't round that correctly. Yeah, sorry, 381. Let's double check sig digs here. 3. Yes, 3. Okay, 381. Sorry, my bad. All right, so that one's out of 4. The quiz is out of 9. Give them a mark out of 9 at the top. Then put them on top of the Chromebook cart and come get a Chromebook.